This is 7.1, part 4. We are working the same kind of problem we just did. We're supposed to work it twice. First we plug in x equal 2, and then we plug in x equals -3. Okay, so for the first one, which is x equal to 2, we plug this in. -2 times 2 raised to the third power over 3 times 2 plus 9. This breaks it into two problems. I need to simplify inside the parentheses here. -2 times 2 is -4 to the third power over 3 times 2 is 6 plus 9. Use -4 inside parentheses and then raise it to the third power, and you get -64 over 6 plus 9 is 15. I would reduce this if I can, but it does not reduce, so that is my answer. Now for part B. We are supposed to plug in x equals -3. That would give me -2 times -3 cubed over 3 times -3 plus 9. -2 times -3 is +6 cubed over 3 times -3 is -9 plus 9. Now, I could go ahead and multiply 6 to the third power. I mean, it's equal to 216, but I see here in the bottom, I'm going to get a 0. And when I have a 0 in the bottom, I didn't even really need to do that arithmetic, because as soon as I knew that, this is undefined. Zero on the bottom is undefined. Okay, now another new topic. Just like with regular fractions, we always write our rational expressions in lowest terms. You'll know that you have it in lowest terms when the GCF of the numerator and the denominator is 1. That is when you've canceled everything out that they have in common. Okay, so let's look at a problem. Let's look at some more information, sorry. Okay, the fundamental property of rational expressions is that if you have p times k over q times k, we can simplify that to p over q. Basically what this is saying is that these two are both divisible by k, and if you can divide the same thing out of both of them, you're allowed to do that. This also works the other way. If I have something like this, I'm allowed to multiply the top and the bottom by something, and it's still the same fraction. Okay, we've dealt with this before. If I had 1/2, I'm allowed to multiply top and bottom by 4 to get 4/8, and it's the same thing. Whereas here, both of these are divisible by 4. I can divide both by 4, and I get to here. We're just going to be dealing with it with variables. Okay, so in order to get things in lowest terms, you must factor the numerator and denominator as much as possible before you can cancel out anything. All right, you cannot cancel things out if they are added or subtracted to something else. Remember, fractions are divisions, and division only undoes, quote unquote, undoes multiplication. So if I am using my calculator and I accidentally multiply something by 2, but I didn't mean to, I can divide by 2 and get back to where I came from. They undo each other. Okay, so let's look at this example. We're supposed to write these expressions in lowest terms. Well, right here, they've factored everything for us, so we don't have to worry about that. We're going to be able to do this without writing out this step, but remember, this is to the first power, this is also to the first power. I have the same thing here and here, and I'm looking at the same thing being inside parentheses. I have an x plus 1 factor, which means it's in parentheses, over an x plus 1 factor raised to the second power. I'm going to be able to use my power rules, but I'm going to write out a step here that you would not normally go through. This is the same thing as x plus 1 times x minus 1 over, since this is squared, x plus 1 times x plus 1, because squared means it's multiplied by itself. Well, look here. I have the same thing on the top and bottom here, so let's cancel that out. That leaves me with x minus 1 over x plus 1. You can keep these in parentheses. The parentheses technically don't have to be there, but if you're putting them there, it will help you remember that they cancel out as a unit or not at all. It is tempting to cancel out those ones, but you cannot do that. Because if you cancel them out, you're using division to undo an addition or a subtraction, and that doesn't work. You can't cancel these out either. These are totally different things. So you can't reduce it any further. This is your answer. Now, a way to do that from here by just looking at the exponents. Remember that we had that power rule. I'm looking for my card real quick. Right here, that says if you have the same base on the top and the bottom, you're allowed to subtract those exponents. Well, we can do that here. I have the same base, and I could write 2 minus 1, which is going to give me a 1 down here. Often we'll mark that out and change that to a 1, and we're there.